Ciao a tutti and welcome back into my channel. AndrewC is back with a new video. During these last days I was looking on YouTube for review and information about coil. I have found a lot of tutorials of super complex coils, but just a few of them were explaining the difference between one coil and another. This, in my opinion, is a gap, especially for new vapers who start making their first builds. So, let's try to put together some useful information and let's deepen a bit the knowledge of the coils. The coil is a really important component of an electronic cigarette. The coil is the element which transforms the e-liquid in vapor through the heat. The best atomizer over the best mode with the best circuit can return a really bad vaping experience if the coil used is not the right one. Let's split this guide in three main topics. We will talk about wire materials, deepening the knowledge of some of their characteristics, coil parameters, in order to have some evaluation parameters, and the coil types, where we will see simple and complex coils. So, let's start. As probably most of you know, the coils for vaping are made with specific materials. The most common materials are Cantal. It is the trademark for a family of iron, chromium and aluminum alloy. This material is known for its ability to withstand high temperatures. Nichrome. It is an alloy of nickel, chrome and, often, iron. This material is known also for its ability to withstand high temperatures. Stainless steel. It is a steel alloy containing chromium. This alloy is well known for its corrosion resistance. Nifetal. It is a nickel iron alloy for use at temperature up to 600 Celsius degree. It is less common than the other materials, but it has characteristics useful for a specific type of vaping that we will see later. The next minutes of this video will be a bit boring, but they are really important to fix a common base for the next steps. Each one of the materials listed before has a specific characteristics. The most important one, in my opinion, is the specific electrical resistance. This property quantifies how strong the material resists to the electrical current, and it is measured in ohm by meter. The higher is this value, the higher will be the resistance that the wire will offer when the electricity tries to cross it. The best way to fix ideas, in my opinion, is to transform them in something more practical. So, let's try to fix some numbers. Let's consider a 5 wraps coil with inner diameter of 2.5 mm, no spacing between the wraps, and with 5 mm legs. The wire we use is a 26GA. As you can see, the final resistance value varies by varying the material considered, and the material listed in this video have 4 different specific electrical resistance values. But there's another important characteristic of the material's specific electrical resistance. It varies depending on temperature. When the temperature increases, the specific electrical resistance increases too. For some materials, like Cantal and nichrome, the variation with temperature is absolutely negligible, so we can consider the specific electrical resistance of these materials as a constant over temperature. The specific electrical resistance of stainless steel and nifetal varies a lot with the temperature, and this variation is used by the electronic circuit of the box when we vape in temperature control. During vaping, the circuit reads continuously the resistance value and, knowing the specific electrical resistance of the wire used, estimates the temperature of the coil, limiting the current supplied when it reaches the desired temperature. Okay, the boring part of the video is gone, so let's jump to the second topic of this video. Let's talk about the coil parameters. Now that we know some properties of the materials used for the wire, we have a good base for selecting our coil. In my opinion, there are three important parameters during the coil selection: the resistance value, the ramp-up time, and the surface area. The first parameter to consider is of course the resistance value. If you use pre-built coil, the resistance value is indicated by the producer, while when you build your own coil starting from the wire, the formula to calculate the resistance value is resistance equal to specific electrical resistance multiplied by the wire length divided by the cross-section of the wire. Again, let's transform this to something practical. Let's consider the same coil we considered before, so a 5 wraps with inner diameter of 2.5 mm, no spacing between wraps, and 5 mm legs. This time we consider a thinner wire. We use a 28 GA. As we can see, the resistance and the specific electrical resistance value increase with each material considered. This formula gives us two additional fundamental parameters related to the wire: the length and the cross-section of it, and their effect on the final resistance value. The more wrap we do on the jig, the longer is the wire we use, the higher is the final resistance we obtain. At the same time, the thinner is the wire we use, the smaller is the cross-section of the wire, the higher is the final resistance value we obtain. The second important parameter is the ramp-up time. The ramp-up time is the time that the coil needs to reach the temperature after the activation. Of course, this value depends on the power applied by the box, but in general we can say that the lower is the specific electrical resistance of the wire, the shorter will be the ramp-up time. At the same time, the more complex is the coil we use, the longer would be the ramp-up time. The third important parameter, in my opinion, is the surface area. With surface area is meant the area of the coil which vaporizes the e-liquid. The higher is the area, the higher is the amount of e-liquid vaporized, the higher will be the return in terms of flavor that the coil will offer. Simple coils offer reduced surface area, while complex coil, thanks to their design, will offer a greater surface area. All these values determines the most important character of the coil, known as a heat flux. We can simplify this concept as the correct balance between the mass, the surface area, and the power applied to the coil. Okay, with these parameters in our pocket, we can jump to the last and probably the most interesting topic of this guide. Let's see now the coil types. During this video, I often spoke about simple and complex coil. If you don't know how to distinguish them, here's a quick explanation. A coil is defined simple when it is made with a single wire, while it is defined complex when it is made with more wires. The simple coil is the most common, so it doesn't make sense to spend time on it. More interesting are the complex coils. The simplest complex coil is probably the one called twisted. The wire used for this coil is composed by two wires with the same diameter, twisted together and then wrapped around the coil jig. But I'm sure that you are not here just for a twisted wire, so here are some of the most common complex coils. Klepton. The wire for this coil is composed by two wires, one wrapped around the other. The central wire, called core, is bigger in diameter than the one wrapped around, called wrap. Fused klepton. The wire used in this coil is similar in concept to the klepton, but the core is made with multiple wires. Alien fused klepton. Evolution of the fused klepton. The alien wire is composed by 2 or 3 core wires wrapped using an outer klepton wire that has been decored. Staggered fused klepton. The core of this wire is made with 2 klepton wires where the wrap is spaced. These 2 klepton wires are then wrapped together in a single wire, exploiting the free spaces left by the 2 core wires. So the wrap wire is staggered. There are other variants of this coil where the core differs. This variation of the core add the name like framed, staple and many others, but in case we will see them in another video. This is it for the guide to the coil vaping, and I hope you enjoyed it. Let me know what do you think about in the comments, if this video is interesting and if there's something else that you want to deepen. As usual, useful links are in the description as well as my social media. See you next time. Ciao!